Alright, so we are almost done with the Lexing, and yeah, basically we are trying to build a compiler written in the same language that we are trying to compile, because we already have the compiler made in C, so we just want to self-host it basically. And yeah, we started with the Lexer. We almost finished it because, you know, pretty easy. We just copy pasted the code from the C code base and got most of the tokens done. The only token that we have left to do is strings, which those are usually the worst. I mean, comments are also a bit difficult, but not, you know, as difficult as strings. Strings are a bit more tricky. So yeah, this is what we have to do today: fix the strings, and that would be the entire Lexer, I would say. And yeah, the plan for you know, next would be to get the AST and you know, go to assembly, do all of that stuff. So yeah, I mean, obviously it will take us much less than the first implementation, which took 25 days. This one will probably took like, I mean, it took longer because I didn't code, I was doing also random things in between, so it took more like month and a bit, but like continuous time that I spent was like 25 days. So yeah, this will probably take much less. But yeah, so yeah, all the code was pretty much done together, right? So there's really nothing that new. Maybe only the errors for token illegal. I think there is something new there. Let me just check. So I think where is the comments? Yeah. So for the comments, I just added the error check, right? So in this language we don't have a return statement. So the only way to break the loop is to add another condition, and yeah, you know, that condition is this has error, which is false. We make it true, and then it breaks because it reaches the end. So that's the only extra thing. And I added this token error, which is the exact same as token, so it's like an enum, because, you know, we don't have enums in cool. We have classes because it's OP, but we can think of these as enums because all of these classes inherit from the base class, and we have this cool feature of, where is one use case, maybe this case feature, which matches on types. So it's like pattern matching basically. So yeah, so let's see, let's start with the topic for today. So we have to do strings, right? So first things first, I would say we need quotes, or I guess quote, right? We need the presentation for quotes, which is gonna be this thing. Now if we go into our, well, I guess let's see what happens if we try to make compiler. So let's try to add a string in here, so something like this. So it gives us illegal character, then an identifier, and then illegal character again. So it considers the quotes as illegal. Right, so that's something. So then let's try to add string into here. So let's try to, let's say, add it here, why not? Else if ch is quote, then we're gonna do something. We need to add the fee here, and now well, obviously we could, you know, take a look at how I did it in the C version, because it's pretty huge, right? So this entire function is what I wrote. I mean, it's 66 lines of code, but it's really like vertical, like it has a lot of lines because of these things, so it's not that crazy, right? So all we have to do is search for the matching quote. Simple, right? So I think we should read a char just to skip it. So read char, so we skip our quote. Okay, and then we have to do while ch, I guess not ch equal to b quote, loop pull. Okay, and I think that this while loop, sure, one thing that we have to do is read char, that's for sure. Although I yeah, we read the char. And then at the end, this is going to be interesting. Huh, I don't even remember what literal, oh, literal, okay, builder. Oh, so I append the character here. Okay, fair enough. That's the way to do it, why not? And here at the end I just read char. Okay. Basically I want to also skip, so this would be like skip first quote, and then here is the inner characters, and this is skip last quote. All right, and that's the main idea. And at the end, wait, sorry, where is it? Here, we need to build our string literal. All right, so let's try I'm thinking maybe we can keep a number that represents the length that we read, so something like something like let length is an int and it is equal to 0, and then we have in. and here length increases by 1. Okay, and the way to build the string would be something like let v is a string, buffer is the entire buffer that we have, so we can sub string it. We also need to keep the position, and here is length. Token string literal with value v. Oh, position is something that we already have because it's from here, but we should do position +1 because we want to skip this. Yeah. Oh, and here comes the, well, actually, yeah, we want the value to start at position +1, but I think that the position of the token starts on the quote, so I think it's fine that we have this one here, because yeah, let's see. So now if we retry our thing, we should get a string literal instead of that. Pretty cool. And if we run this, almost everything runs. Obviously we have special characters that we need to take into account, something like that also, and add the errors. So let's try to do that. All right, so let's see. Obviously if we encounter end of file, that's an error. If you remember from, let's call it the real implementation. So let's take has error. Should I actually make a separate function for this? Like, should this actually be, let's say, a function like this, skip comment, and it should be, wait, how is it called in C? String literal. String literal. Yeah, I mean, cannot be bothered. Let's keep it here. Although, I mean, yeah, why not? Let's make a separate function because this is gonna get super huge. So let's save it. String literal. I was thinking it can return maybe a token, right? Because it can do like illegal token or something like that. So instead of all of this, we'll have string literal. I'm wondering if I should make read jar outside or not. I think inside is better. String literal. So it's gonna be like this. Pretty simple. Now I only need position, so position it's equal to pos, which is an attribute on this thing on the Lexer. Right, so if we check again, it should just work. Okay, it didn't. I think I forgot something in the let. That's what it looks like. 283. That's yeah, I mean the let statement looks pretty trash, so maybe I can figure out a way to make it better this time around. Okay, so now everything is working. Yeah, so I was thinking of this has error to be used in combination with this, and not has error. But I think the first thing would be to do the special characters first. Oh, and this is also another thing. We cannot really do this right here. I mean, this works right now, but it's not gonna work in the long run. We have to build a string from scratch. So basically, let's say string is gonna be an empty string, right? And here, before we skip char, we want to curious what ch is. Oh, it's a character. Okay, so let's say we don't use length. Wondering if I should have a wait, what is ch, like what type does it have? It's a byte. So let's have a char, which is gonna be byte, and leave it null for the moment because we are going to initialize it. So char is going to be equal to ch. I could make it string and say here to string. Okay. Okay, and then we have string is equal to string dot, and that's what I don't remember in the prelude. Concat, I guess. Concat char. Actually, I think yeah, it actually needs this, but still wondering if I should keep it as I mean, it's still less conversions, honestly, so it's value string, right? Let's see if this thing still works. Where is this? 298. Oh. Yeah, I mean, still looks like it works, right? the same test cases fail, so perfect. Okay, so now we can compare char with different things. For example, if the character is a backslash, so if char, see here at this point I'm thinking I could use byte just for these comparisons, but at the same time then phi. So here we can read another char. So then if ch is equal to n, see, I mean, yeah, should be, maybe it's gonna be cooler to use byte here. Actually, no, I don't think so. Okay, let's leave it like it is. String is equal to n. Then we set char to be new line, else tbf is equal to t, then slash b. And you know, any other character would become the character itself. So yeah, I think it's 4, right? 1, 2, 3, 4. Yeah, 4. So this would be some of the special characters. Let's see. Obviously. So we got 292. Oh yeah, here it needs the blocks. .306. Else we don't do anything. I think 0 is a better one. 308. Okay, that was good. And also the special characters work. Perfect. So this was the only thing. I mean, I don't know about it. A lot of toStrings, but it's fine. I guess. So the last thing that we have to do is the errors, right? So I guess the easiest error is if the string is too long, so that's the easiest one. Okay, so in here if length, if string.length is, I guess, greater than 124, then we do the error, else we do this. So it's going to be a token illegal with, I guess, position is going to be applied automatically, and the error should be string constant too long. So with error, right? So token legal has with error, the rest of the tokens don't have it. It's where is it? It's here. Alright, so only token illegal has errors, and the error that I want to add is this one, token error constant whatever too long. With error, and I have to say no, and yeah, it doesn't have anything. So this would be how we handle too long, but I guess I did an oopsie doopsie. Yeah, so it's the other way around. 124 is less than. Okay, and I think this should do it. Obviously it's not done yet, so maybe we can even tests Lexer 18 CL. Right, so string constant too long, that's good. Okay, so what's the next thing that I can do is EOF. Why not? Let's try to do EOF. That's gonna happen somewhere here. So see, maybe this is why no, it's funny because I could use -1 for EOF. Right, and I think it's still gonna work. Oh, I mean, -1, right? Yeah, it still works, fine, perfect. So yeah, this is, well, I mean, I can use CH for these things, so it doesn't matter. Let's say this is the part where we build a string, so this. And first we have something like if ch is equal to beof, then else 0. So if it's EOF, then we have to do string contains EOF. And I think best way to do it, I mean, this should be on the else case then. Should it be also with this? I think so. So this entire thing needs a block anyway. Jesus. Okay. Oh, but the inner thing doesn't need a block, so that's at least one thing. Okay, so has error becomes true. This is similar to this, right? And this is interesting. Has error, and we could also keep error, which is gonna be optional token error, for example, optional token error, right? Because we can just, and here error becomes a new sum with value, or I guess because this one was returning an optional, but in this case I don't care about optional. I can keep it as null if it's false. So error can become new string contains EOF, right? That would be the error. And now here, if has error, or I guess even not is void error. No token illegal with error, right? And could turn this into and is void error. Right? Is void. So yeah, let's see if it compiles. Funny enough, it compiles. So then let's try with a null character. Token error string contains null. Okay, so for the null character I need to actually do it. So it's 0. Like actually 0. Let's see. String contains null character. Yes, invalid character. I mean, something weird in this thing. Let's see. Why would it say invalid character? Maybe it's because of weird characters that we print. So let's see what's next. New line. I think that's everything. Else if ch Is it new unterminated? I don't remember. I think so. I need another one. Semicolon, and then it just dies. The weirdest error ever. So it's class name lbrace and then illegal, but it's printing it wrong. What? There's like a really weird character and I don't know what the fuck that character is. It's like a tab or what? Identifier long. Let me just double check. So in tests, yeah, it's lbrace ident long, so I have those, but there's an illegal invalid character. But I mean, it's legal. Okay, so it's a weird symbol then in the file, which this thing doesn't really like. But I cannot figure out what that character is. What? Let's take this thing into test and let's see like what this thing is about. So now it looks fine. Okay, what if I add so maybe it's because of the null. So after reformatting the thing, it kind of works, right? But I'm wondering what that character is that it says it's invalid. So let's go in the compiler. Where I print the token illegal here. So, token illegal. Okay. Let's do a case t error of isac, and if v is, let's say, or I guess error is token token error invalid character. We do something here, and otherwise we can even do like otherwise object, it's something else. Out int okay, let's do like 0. Let's see if it compiles. Okay, it compiles. So then I need well, I could do this thing here. I could say new byte from string v to int. That's the character code. 13. ASCII? Huh. The fuck is 13? Carriage feed. Backslash R dead, for fuck's sake. Yeah, I think how did I handle backslash R in this one? Or I guess I did not handle it, it's just worked. I also did skip until semicolon in these when I was getting errors. So maybe that's also a thing that I have to do. String constant too long, that's working. Yeah, I think I also have to read until semicolon or something. Skip until semi, which I guess it's the same as skip until new line, but it's gonna be with semicolon. So skip until semicolon. I have it, perfect. So I still don't escape the blocks. Skip until semicolon. Oh my god, does it work? Oh wow, I mean that's a huge win. The auto indentation works, kind of. So we skip until semicolon, right, on all error cases. Here, here, and here. Skip until semi. Maybe that's gonna help. Let's see. Still doesn't help. We have those backslash r's at the end. So it's like in here that is the problem. Oh, because it's not white space. Skip white spaces. So let's go into prelude.cl and is space or c is equal to backslash r. Yikes, Windows users did. Oh yeah, didn't help. New byte from int 13 I cannot compare self with this. Well, I could say equals this. Okay, now it worked. So what isn't ch, or how is it word? One of these things. What's the order of this? 13. Imagine my compiler maybe not picking that up or whatever. I don't know. Wait, what's the order of backslash n? 10. Yeah, anyway. So now it means that everything is working fine. So this is not needed. Okay. So it looks like we get the errors as we should. It was like a problem with white spaces. Why shouldn't I be like surprised about that? Okay, so yeah, like how parsing this, let's see if it actually runs the passes the tests. Doesn't. Let's see, diff tests Lexer 18 ref. So something with semicolon, you're saying. So it's like line 14 in my thing, right? Oh yeah, I mean, maybe this is the reason to use bat instead of cat. 2, 4, 10, 12. I don't see it. What the fuck was it? It says 14, but I don't know how to use diff, to be honest, so let's also check them side by side. I mean, when I say side by side, maybe I mean side by side. So let's do ref on one side and this thing on the other side. So it's like string constant or not, both of them have semicolons at the end. That makes sense. This thing with string contains null character. String contains null character. I don't have the semicolon. That's one thing. alternated string constant. But I don't see where the extra one is. Jesus. Yeah, like only this semicolon is missing, right? Colon, class name assign, illegal. Ooh, after this illegal alternative, it's missing semicolon. Okay, so skip until. Skip until, so it's maybe I'm doing an extra read char at the end or something. So because here it's skipping, oh, and it's instantly returning. So this read char shouldn't happen if we are in this case. It should only happen on these cases. So maybe I can do a block statement in here. Like this. Holy shit. Something like this. And I could maybe add this one here, right? Because this thing already skipped whatever it was skipping. So now if we run the Lexer, all tests passed. Perfect. That's what I wanted to see. Okay, very nice. So yeah, like how string literal parsing works, we take the first quote, then while we are not finding any other quote or any errors, we continue reading the string, right? We read it character by character. We handle these special characters like merging backslash with whatever character it's next. So we, if you know in Python, the wrapper thing, so which adds like quotes and stuff. I feel like this is the reverse of that, basically. Like if you have backslash and then a character, it unescapes it, so it does the reverse of escaping. And yeah, then we concat, we append it, and here we handle the result of the while loop. So for example, if we had any errors, then we just say, okay, there was an error. Otherwise it means that we have a string, so we skip the last quote. Then we have to check, is the string too long? Then it's an error. And if the string is not too long, then it's fine. So that's how the thing was working. So yeah, string literals for you. And I guess the Lexer is now complete for this thing, for this step. So yeah, I think it would be cool to have command line arguments, or at least be able to parse them via an object or something. Yeah, maybe that would be interesting, but But yeah, I guess for today we are done actually. So yeah, I mean, we managed to finish the Lexer, which is pretty nice. And as I said, the next step would be to work on the AST. But yeah, I really think that command line arguments, right? That'd be cool to have in the language. And I guess those usually are in the environment variables or something. So maybe we can just do it using syscalls. I don't know though. I have no idea. But yeah, I mean, we can also have like this being the Lexer, right? And we run it in stages. So for example, all the source code from here is gonna be Lexer, like a library, and then we have a main for showing the lexing stuff, a main showing the AST, and so on. But I feel like that's I mean, still command line arguments would be best, but at the same time I think that that also makes sense. Right, yeah, I mean, sure, makes sense. So basically just renaming this thing into a Lexer, for example, or like print Lexer or something. Sure, yeah, why not? And then maybe have an sh script that is used for the checker, right? So something like that. But yeah, I'll have to think of that on my own because it's probably is not going to be interesting. So yeah, we actually managed to get the language to Lex itself, tokenize itself, which is pretty cool. So yeah, we'll see in the next one for the, I guess, AST, right? Okay, let's see what happens if we let's have a sneak peek. So at least it parses it, right? So yeah, that's but we want to get the AST, which would be, let's say, build main and AST 01. Oh, it's, I mean, it's assembly, but yeah, whatever. I don't remember which arguments were here, but that's the latest, like, final stage. So yeah, we got the lexing done, so see you in the next one.